Alright guys, we're going to go ahead and do notes for 1B, binomial expansions. So first off, expansion basically just means multiplication. Okay, so you have two binomial expansions there. Binomial expansion of a plus b to the second is a squared plus 2ab plus b squared. The binomial expansion for a plus b to the third is a cubed plus 3a squared b plus 3ab squared plus b cubed. So I got those just by multiplying those out. A plus b to the third be like a plus b times a plus b times a plus b. Okay, so we can make this a little bit easier because you can imagine the more we do, if we do a plus b to the fourth, that's going to get pretty hefty. So we have this thing called Pascal's triangle. Pascal's triangle gives us the coefficients of binomial expansions, which is really cool. So Pascal's triangle starts out with 1, 1. That is row 1. And then the next row is 1, 2, 1. That's row 2. And then it's 1, 3, 3, 1. That's row 3. Then 1, 4, 6, 4, 1. That is row 4. Then 1, 5, 10, 10, 5, 1. That's row 5. That keeps going on forever. So how you get to each row, you add the terms, and like 1 plus 1 is 2, and that gives you the next term in the middle. It always starts out with 1 and ends with 1. 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 3 is 6. So on and so forth. So that's how you get the next row if you know the previous row. Okay, so one thing to notice is for any of the expansions, n is just the power. So for the expansion a plus b to the n, where n is a natural number, 1, 2, 3, 4, 5. Those are all natural numbers. Okay, so as we look left to right, the powers of a decrease by 1. So if we look at here, we have 3, then 2, then 1. So the powers of a are decreasing, while the powers of b are increasing by 1. So here we have no power of b, that's the power of 0. Then we have a first power, second power, third power. Okay, and also notice that the sum of the powers of a and b in each term is n. So 3, n is 3. 2 plus 1 is 3. 1 plus 2 is 3. That's also 3. The number of terms in the expansion is n plus 1. So if n is 3, the number of terms we should have is 4. So we have 1, 2, 3, 4 terms. All right, and then the coefficients of the terms are the nth row of Pascal's triangle. So these coefficients, since n is 3, they come from row 3. All right, so let's go ahead and do a few examples. So this is example 2 from your book. I kept the examples labeled from your book, so you can always go back and look at the self-tutor. Okay, so we have use a plus b to the third equals a to the third plus 3a squared b plus 3ab squared plus b cubed to find the expansion of 2x plus 3 to the third. Okay, so here we've got kind of a template. It's almost like a formula that we're going to plug stuff into. So we need to know what a is, what b is, and what n is. Okay, so a is going to be 2x, so that's a. That's the first thing that part of that binomial. And b is going to be 3, and our n is our power 3. Okay, that just tells us what row we're going to use, but we actually already have the formula, so we don't really need that. Okay, so if a is 2x, b is 3, we're going to plug that into a cubed plus 3a squared b plus 3ab squared plus b cubed. But I'm going to replace a with 2x, and I'm going to replace b with 3. So I'm going to have 2x. Oops, sorry. Pen stopped working. Hold on. So we're going to have 2x to the third plus 3 times 2x squared And then our b is 3 times 3. So plus 3 times 2x times 3 squared plus 3 cubed. Okay, so 2x to the third, it's going to be 8x cubed plus 2x to the third, that's 4x squared. So 4 times 3 is 12, times 3 is 36x squared, plus 3 times 2 times 9, so that's what 9 is going to be 54x, plus 3 to the third is 27. So that is our expansion of 2x plus 3 to the third without actually having to FOIL it all out. Pretty cool. Okay, so let's do another one. So we have x minus 3 to the third. So here we've got a is, oops, pen stopped working here. We have a is x, and b this time is negative 5. So when it's a minus there, b is going to be negative, all right? So we've got a cubed plus 3a squared b plus 3ab squared plus b cubed. You don't have to write that out every single time. It's just helpful. Okay, so we're going to plug x in for a and negative 5 in for b. So we have x cubed plus 3 times x squared times negative 5 plus 3 times x times negative 5 squared plus negative 5 cubed. Okay, so x cubed is just going to be x cubed. Okay, pen. Sorry. All right, so x cubed is just x cubed plus 3 times negative 5 is negative 15, so really I should do a minus there. Minus 15x squared. And then negative 5 squared is going to be positive 25 times 3, 75x. And then negative 5 cubed is negative 125. So that's our expansion of x minus 5 to the third. All right, now example 3. Find the fifth row of Pascal's triangle. So I actually already have it up there, but I'm going to go ahead and write it out again. So our first row is 1, 1. Second row, 1, 2, 1. Third row, 1, 3, 3, 1. Fourth row, 1, 4, 6, 4, 1. And then the fifth row, 1, 5. 1 plus 4. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. 1. Okay, so that is our fifth row. All right, binomial expansion of x minus 2 over x to the fifth. Okay, so this is going to be a is going to equal x, and b is going to equal negative 2 over x. Okay, so that we are going to go ahead and do. All right, so for that, we're going to use the fifth row of Pascal's triangle. So we're going to have 1a to the fifth plus the next coefficient is 5. Power of a is going to decrease by 1, so that's going to be a to the fourth. And we're going to have a b because the powers should add up to 5 because n equals 5. Sorry, pen stopped working for a second. N equals 5. Okay, and then the next coefficient is 10. So we have 10, a to the third. We continue to count down. We count up with the b's. Then the next coefficient is 10, a squared, b to the third, plus 5 b to the fourth plus b to the fifth. Squeeze it in there. Okay. Next, we are going to have plug in our x for a and -2 over x for b. So this is going to be x to the fifth plus 5 times x to the fourth times -2 over x plus 10 times x to the third times -2 over x squared plus 10 times x squared times -2 over x to the third plus 5 times x times -2 over x to the fourth plus -2 over x to the fifth. Okay, so that's what we've got there. All right, I'm going to simplify each of those. So x to the fifth is just x to the fifth. Okay, so we've got 5 times x to the fourth times -2. Well, 5 times -2 is -10. And you have x to the fourth over x. That x stays on the bottom. I'm going to simplify that in a little bit. Okay, so then the next one we have 10 times x to the third. And then we have -2 to the second, which is going to be +4. So 10 times +4 is going to be 40. X to the third on the top of that fraction over x squared on the bottom, because that second power goes to both parts. All right, now we've got 10 times x squared, and -2 to the third is going to be -8. So it's going to be -80 x squared on top over x to the third. And the next one is going to be 5 times -2 to the fourth. -2 to the fourth is going to be +16. So 5 times 16 is going to be 80 x over x to the fourth. And then the last one is going to be -2 to the fifth, which is -32 over x to the fifth. All right, let's go ahead and simplify these fractions. So this is just x to the fifth plus, and then we have x to the fourth over x. So that's going to be -10 x to the third. So I'm actually going to put a minus there. So -10 x to the third. And then here we've got 40 x to the third over x squared. So x to the third over x squared is just going to cancel out. So it's 40x. Okay, and then we've got -80 x squared over x to the third. So now we've got more on the bottom. So this is going to be -80 over x, because 2 minus 3 is -1, which means there's more x's on the bottom. So another way we could do this is we can write x to the third as x times x times x, and x squared is x times x. 2 of them cancel on the top with 2 of them on the bottom, so you're left with 1 on the bottom.